Okay, we're going to be moving away from inequalities into proportions and percents and ratios and rates and how kind of some of those tie together. We're going to start on Chapter 4, Section 1 with proportions, and the most important thing in this section from the book is unit conversions, how to be able to convert from one thing, one amount, or one rate to another. Before we get to that, we got a lot of vocab and understanding of words to get to. So we're going to go through this, and the students that have done this have written down vocab for Chapter 4. And so you've written down something for a ratio, something for a rate, something for a unit rate. I want us to decide which is a ratio, which is a rate, which is a unit rate. Starting with, at Pate High School, there are 214 boys, 216 girls. Second one, 80 miles per hour. Number 3, costs $45 to fill up my car's 15-gallon gas tank. Number 4, on Halloween I ate 3 candy bars for every 1 candy bar my daughter ate. Number 5, James ran 3 miles in 18 minutes. Number 6, the cost of Malt-O-Meal brand cereal was 8 cents per ounce less than the leading brand. Number 7, Jessica can do 4 math problems in 1 minute. Okay, so let's go through each one. The first one is a ratio. Ratios always have to do with similar units, in this case students or boys and girls or people. A ratio compares two similar items, boys and girls in this case. Another ratio could be like teachers to students. Okay, those are ratios. A rate is something that compares two things with different units. So for example, 80 miles per hour, you have miles and you have hours, and you're comparing those two things. That's a rate. A unit rate is a specific rate that always has a denominator of 1. So with that in mind, number 1 is ratio. Number 2 is a unit rate, because what you're saying is I drove 80 miles in 1 hour, per 1 hour. So that denominator is 1. If you wrote this as a fraction, which I will do real quick, it would be 80 miles per 1 hour. Costs $45 to fill up my car's 15-gallon gas tank. Now, if I wrote this as a fraction, it would be $45 over 15 gallons. Is the denominator 1? No, it's not. So that is just a rate. On Halloween, I ate 3 candy bars for every 1 candy bar my daughter ate. So the 3 to 1, those are similar things. That's a ratio. Okay, comparing the number that I ate versus the number that my daughter ate. James ran 3 miles in 18 minutes. That is a rate because you're comparing miles to minutes. Those are different units. So that means it's just a rate. The cost of Malt-O-Meal brand cereal was $8 per ounce less. That's your unit rate because you have 8 cents over 1 ounce. Okay, so basically every 1 ounce is 8 cents. Jessica can do 4 math problems in 1 minute. So that is also a unit rate. You're comparing the number of math problems versus the number of minutes that you have to go by. So 8 math problems in 2 minutes, 12 math problems in 3 minutes, so on and so forth. That's a rate. Okay, so unit rates, they're everywhere, and we use them the most for a couple of reasons. But think about some unit rates that you might see out in the world. Miles per hour, rotations per minute, gallons per mile. Those are some examples. Try to brainstorm 2 or 3 more and see if you can come up with some more. Okay, moving on. Why do we like unit rates? First, they make comparing things easy. So for example, if it costs 72 cents for 16 ounces of apple juice, that's 72 over 16. $1.20 for 32 ounces of apple juice, that's 120 over 32. And $1.60 for 65 ounces of apple juice, that's 160 over 64. Which one gets you the best bang for your buck? And a lot of people could probably figure that answer out just conceptually, but in order to prove that one is cheaper than the other, what you can do is you can find the unit rate. How would you find the unit rate? Simple. Divide the top by the bottom. If you want to find this unit rate, you take 0.72 and you divide it by 16. That's going to find us the unit rate. 120 divided by 32. That's going to find us the unit rate. 160 divided by 64. That's going to find us the unit rate. And that's going to be per 1 ounce. And that's going to be per 1 ounce. And that's going to be per 1 ounce. And that is going to help us recognize which one is less on top. Once you have denominators that are the same, then you can figure out which one's actually more or less. It's a fraction. Also, unit rates make it easy to find equivalent rates. For example, if I eat 25 cookies in 2 days, how many cookies will I eat in 5? One way to do this is to double how many days there are, which is 4. You'd have 50 cookies, but then you have to add one more day. We need to know how to get one more, or how many cookies are in 1 day. To do that, find the unit rate. 25 divided by 2 is 12.5. So I ate 12.5 cookies per 1 day. Then it's a very simple process of multiplying by 5 because you want 5 days. So 12.5 times 5 is 62.5 cookies in 5 days. And that would be your answer. So, we're going to get to a problem like this. If you travel 123 miles in 7 hours, how fast is that in feet per second? And that's what we're going to be looking at. So, we're going to write it as a rate with the units there. You need to, when you're doing unit conversion, you need to make sure that you have miles written and hours written because you're going to be using those during the conversion. Now, this is called dimensional analysis, and it looks really scary, but what you're doing is basically getting rid of miles and changing it to feet. So, there's a lot of stuff here, but I color-coded it so you could see the similarities. And what I want you to notice is similar colors are diagonal from each other. Miles and miles is diagonal. Minutes and minutes is diagonal. Hours and hours is diagonal. It looks really scary, but it's actually not so bad. It's a very methodical process. Because if I want to change from miles to feet, I need to know how many feet are a mile. That is a conversion factor. 5,280 feet is 1 mile. So I'm going to put a fraction here where mile is on the bottom so that diagonals are the same, and then feet's on the top. 1 mile is 5,280 feet. That's where this fraction comes from. The next one is 1 hour and 60 minutes because 1 hour equals 60 minutes. Now, I could put the 60 minutes on top and the hour on bottom, and that's also a conversion factor, but I want diagonals to be the same. So if I have hours on the bottom, I want to put my hours on top. And then finally, 1 minute is 60 seconds, so I'm going to make 1 minute on the top because I want to get rid of minutes, and seconds on the bottom. Now, what's great about this is, once you have the same size, same units diagonal, you can just cross out all the similar units. And what are you left with? Feet. And you're left with seconds. The last step is to just multiply all the tops together. 123 times 5,280 times 1 times 1. 7 times 1 times 60 times 60. Now that's not very helpful for us right now. That number is really weird. It's about 650,000 feet in 25,000 seconds. I have no idea how long 25,000 seconds is. Well, actually I do. It's 7 hours. And 650,000 feet is 123 miles. But I need to know what that is in my mind. So I'm going to convert this to a unit rate. So that number, 149,440 divided by 25,200 is 25.77. That is 25.77 feet per 1 second. So I divide the top by the bottom and I get my unit rate. So that's 25 feet per second. Can you imagine the classroom that we are in? That's about, in 1 second, going from one side of the room to another. A little less than the entire room's length. So, convert 565,900 seconds into days. See if you can do it. And you need to know how many seconds are in a minute, and how many minutes are in an hour, and how many hours are in a day. Okay. And you're going to go from there to there. So 60 seconds is 1 minute. 60 minutes is 1 hour. And 24 hours is 1 day. These are your three, and I'm sorry about my handwriting, my tablet's a little bit broken. These are your three conversion factors that you're going to create rates of, ratios of. Okay, and you're going to make sure that you set up your units so that diagonals cancel. So the same units are diagonals from each other, so they cancel out. And then multiply the tops and multiply the bottoms. Finish the worksheet I gave you. If you didn't get a worksheet from me and you're doing this as missing work, then you need to come to my class and get it from me. The unit conversions worksheet. Good luck.